explain quantum mechanics to a child. So quantum mechanics is the base theory, we think. I think people tend to think of quantum mechanics as something that applies to atoms and electrons and particles, but not to us. And that's not right. So quantum mechanics is the theory that describes everything. The point is, though, it produces, when you look at big things, it produces behavior which can be more accurately or more usefully, not more accurately, but more usefully described by things like Newton's laws. It is necessary to understand quantum mechanics to understand how a transistor works, for example, or how a laser works, or how, of course, a nuclear reactor works or the sun works. So it's not just a theory that's a theory of little things bouncing around. It's a theory that's necessary to understand a lot of things that we take for granted today. And it's an unusual theory. It's strange because it's got probabilities in it. And it was Ernest Rutherford, actually, so famously got the Nobel Prize at Manchester for discovering the atomic nucleus. But he pointed out that in the late 1800s, early 1900s, when we start looking at radioactivity, you see that radioactive decay is a probabilistic process. So it means that given something like a uranium nucleus, you can't tell, even if you made 100 uranium nuclei at the same time, you could just make them, then you can't predict when any one of them is going to decay away and emit some radiation. Basically, it's probabilistic. And so that idea was shocking to people, that it appears that the world is not like Newtonian clockwork. So I would say quantum mechanics, my explanation is it's a weird theory, it's a kind of probability theory, and but it's the way that things actually are.